Hey, this is Presh Talwalkar. Lev Tolstoy, famous for works such as Anna Karenina and Crime and Punishment, is regarded as one of the greatest novelists of all time. But did you know he was fond of a math puzzle? It was presented in Perelmen's book, Algebra Can Be Fun. I thank Kaustubh for the suggestion. As punishment, a team had to mow the grass on 2 fields. One field was twice the size of the other. The team worked for half a day on the larger field. Then the team split into 2 equal groups. The first group stayed in the larger field and finished mowing by evening. The second group mowed the smaller field, but by evening there remained a portion to do. This remaining portion was completed the next day by one person in a single day's work. The question is, how many people were there in the team? When I first heard this puzzle, it sounded absolutely impossible. Can you figure it out? Pause the video if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. Before I present the solution, I want to review common knowledge for mathematical rate problems. I think everyone learns this in 3rd grade, but in case someone has forgotten this, let's just refresh it. Each person works at a constant rate. It's the same rate for every single person, and this rate is continuous for all units of time. Nobody gets tired. Furthermore, the group work result is the sum of the individuals. So we don't have any synergies, and we also don't have any ill effects of people working together. Of course, this is an abstraction. It's not going to be true in the real world, but for a mathematical problem, this is assumed to be true, and even the inventive novelist Lev Tolstoy was fine with these assumptions. Let me first present one way to solve the problem using algebra. So we know that the number of people times the rate at which a person works times the time that they work will be equal to the amount of work that is done. So let's just set some of these variables. The team worked for 1/2 a day on the larger field. Suppose the number of people in the team is equal to n, and each person works at a constant rate r. Take time to have units of days, then 1/2 a day will be 1/2. The amount of work done is the product of these variables, which is equal to nr/2. At that point, the team split up into 2 equal groups. The number of people in 2 equal groups will be half of n, so that will be n/2. This group stayed in the larger field and finished mowing by evening. So of course they worked at the same rate r, and it will be the remainder of the day, which will be half the day, so time is also equal to 1/2. The amount of work done will be n/2 times r times 1/2, which is equal to nr divided by 4. The total amount of work done on the larger field is the sum of nr/2 and nr/4. This is the amount of work needed to mow the larger field, and that's equal to 3nr divided by 4. But what about the other group? The second group mowed the smaller field, but by evening there remained a portion to do. So we have n/2 people working at the same rate r, and this is for 1/2 a day. So the amount of work done by them will be nr divided by 4. We now have this remaining portion completed by one person working in a single day's work. So we have one person working at the same rate r, and the time will be 1 entire day. The amount of work will be the product, which is equal to r. So if we sum these variables, we have nr/4 plus r, and that will be the amount of work needed to mow the smaller field. So let's take a look at the amount of work between the 2 fields. So we have 3nr divided by 4 for the larger field, and nr/4 plus r for the smaller field. One field was twice the size of the other. So if we double the size of the smaller field, that will be equal to the larger field. So we end up with the equation 3nr divided by 4 is equal to 2 times the quantity nr/4 plus r. All that remains is to solve this equation for n. So let's focus on this equation. We can take a factor of r from this group. We now can cancel r on both sides of the equation. We then get 3nr divided by 4 is equal to 2 times the quantity n plus 4 plus 1. Distribute the 2 on the right-hand side. Subtract 2n over 4 from both sides of the equation, leaving n over 4 is equal to 2. Multiply both sides of the equation by 4 to get that n is equal to 8. And therefore, there must be 8 people in the team. And that's the answer. This is certainly one way to solve the problem, and it is how I approached it. But algebra is not the only way to figure out this puzzle. In the rest of the video, I want to present a solution that uses an area model. This is something that students studying Common Core would understand, but it was a method that was known even 100 years ago. So we start out with the information that one field was twice the size of the other. So let's make a sketch of a field and suppose its area is equal to 1. If we divide this field in half, we can make a smaller field that is half the size of the larger field, so its area will be equal to 1/2. The team worked for 1/2 a day on the larger field. Then the team split into 2 equal groups. The first group stayed in the larger field and finished mowing by evening. So let's focus on the first sentence that the team worked for 1/2 a day on the larger field. So let's say that we have one team working for 1/2 a day. We then know that the team split into 2 equal groups, so we will have half the team working for the rest of the day. So we add 1/2 of a team for 1/2 of a day, and this is going to be equal to the entire field of 1. But what is one team working for 1/2 a day? That's exactly the same as half a team working for 1/2 a day and another half team working for 1/2 a day. So we now have exactly 3 units that are all the same comparable quantity of a half team working for 1/2 a day. So we have 3 such units that sum to be equal to 1. So each of these units has to be equal to 1/3 of the larger field. So the team worked for 1/2 a day on the larger field. That's the one entire team working for 1/2 a day. That will be 2/3 of this field. We can split it up as 1/3 and 1/3. And then after the team split up, worked for another half day, we know the remaining portion is going to be 1/3 of this larger field. So we have 1/3, 1/3, and 1/3. Now let's take a look at the other group. So the second group, which will be half the team, mowed the smaller field for 1/2 a day. But by evening, they didn't finish. So we now have another unit of a half team for 1/2 a day. We know that this is exactly equal to 1/3 of the larger field. So it's a total unit of 1/3. So we can draw exactly this line at 1/3, and this is the amount that this second group worked on until evening. So this is going to be 1/3. Now we know that the smaller field has an area of 1/2. So the portion that's remaining is going to be 1/2 minus 1/3, which is equal to 1/6. This portion was completed the next day by one person working in a single day's work. So we can therefore conclude that one person working one day is exactly equal to 1/6 of a unit. So how does that help us? We now need to figure out what one team can work in one day. So we go back to figure out how many people were in the team. We need to know how much did one team do in one day. So we know that the team started out by doing 1/3, 1/3 in half of a day. Then half of a team worked for half of a day to finish it off, and the other half worked for half of a day to do 1/3 in the smaller field. So each of these is 1/2 team working for 1/2 day. So the total of all of these is exactly going to be equal to the amount done by one entire team working for one day. So this is going to be equal to one entire large field plus 1/3. This is exactly equal to 4/3, which can be converted into 8/6. So one person working one day will work 1/6 of a large field, and one team working in one day would complete 8/6 of the large field, it is obvious that it must be 8 times as many people in the team, and therefore there must be 8 people on the team. And that's the visual way to solve this problem. Thanks for making us one of the best communities on YouTube. See you next episode of Mind Your Decisions, where we solve the world's problems, one video at a time.